Your 22 core profile openGL tutorial, which is the modern openGL you're learning. So we are finished talking about the pipeline, so let's get to the Vertex input. To start to draw something, we have to first give openGL some input Vertex data. openGL is a 3D graphics library, so all coordinates that we specify in openGL are in 3D, which is x, y, and z coordinates. openGL does not simply transform all your 3D coordinates to 2D pixel on your screen. openGL only processes 3D coordinates when there is a specific range between -1.0 and 1.0 on all three axes, which is x, y, z. All coordinates which within this so-called normalized device coordinates range will end up visible on your screen, and all coordinates outside this region won't. Because we want to render a single triangle, we want to specify a total of 3 vectors, with each vectors having a 3D position. We define them in normalized device coordinates, the visible region of openGL, that is normalized device coordinate, in a float array. So we define our vectors data like this, in an array. Because openGL works in 3D space, we render a triangle with each vectors having a z coordinate of 0.0. This way the depth of the triangle remain the same, making it look like it's 2D. So we are doing our triangle. Our triangle does not have a deep, that is a 3D coordinate, which is z, so we want it to be a 2D plane. It makes it look like a 2D plane when we set the z coordinates to 0, 0, 0. So okay guys, normalized device coordinates, which is NDC, normalized device coordinates. Okay, normalized device coordinates. Once your vectors coordinates have been processed in the vectors shader, they should be in normalized device coordinates, which is a small space where the x, y, and z value vary from -1.0 to 1. Any coordinates that fall outside this range will be discarded or clipped and won't be visible on your screen. Below you can see the triangle we specify within normalized device coordinates, ignoring the z-axis. Unlike usual screen coordinates, the position x-axis points in the up direction, which is here, which points to up. That is from 0 here to up. You can see my cursor to up here. So up direction, and the 0, 0 coordinates are at the center of the graph, which is here. That is 0, 0. You can see it 0, 0, 0, 1. So instead of top left, eventually you want all the transformed coordinates to end up in this coordinate space, otherwise they won't be visible. Your NDC, which is normalized device coordinate, will then be transformed to screen space coordinates via the viewport transform using the data you provide with GL viewport. Remember, we set GL viewport in our older tutorial. The resulting screen space coordinates are then transformed to fragments as input to your fragment shader. So again, you can have a bit understanding of how we render to the screen, we draw to the screen. So in the next tutorial, we are going to learn more and more and get started with our shaders. So see me in the next tutorial. Don't forget to subscribe, share, and like, comments. Bye.